welcome to another video. So today we will be discussing about the concept of pH and PI. Now this is a very important concept not only in biochemistry but also very important for many techniques. Namely, in this lecture we are going to study about the application of this pH and PI in electrophoresis to solve problems related to electrophoresis and also ion exchange. So if you don't know how to solve these, you are exactly at the place you need to be. By the end of this video, you will be able to solve all the sums that are related to this. Now, before starting, we need some background information, and that involves the first concept, that is PI. Now, PI, we all know, is the isoelectric point. Now, what is the isoelectric point? To understand that, you need to know that the basic structure of an amino acid consists of an amino group and a carboxy group. Now, this can have three different structures. First structure is, if this particular structure, here you can see the nitrogen would have a lone pair, right? Now, whenever this is in an acidic medium, it would take an H plus and this will be NH3. This would be COOH. Now, since nitrogen has lost its lone pair in forming a bond with this H plus, it will get a positive charge. Now, when this COOH, this also can ionize. So if it will ionize, what will happen? It will lose that H plus. So their H plus will be lost and this will be COO minus. So in case number 1, the net charge on this amino acid would be positive 1 because it has one positive charge. In this case, it will be minus 1 because it has a net charge of minus 1. Now, there can be another state wherein both of these exist in their ionized form. That is, you have NH3 plus as well as COO minus. Now, what is the net charge right here? Yes, plus 1 minus 1, 0. And this point is called as the PI, where the charge on the amino acid, net charge on the amino acid is 0. Now, to understand another thing, how is this related to our topic today? We need to understand that there is a correlation between pH and PI. Now, depending upon the pH, you can tell what the charge on your amino acid will be. So as we just discussed, the amino acid has three chances, three different possibilities. It can either be in the A structure, B structure, or C structure. Now, what decides in which structure is the amino acid? Then the answer is the pH. The pH would decide the charge on an amino acid. But how will it decide that? By the titration curve. The titration curve is one concept wherein you can determine or you can understand the relationship between pH and between this PI. So for that, let us start understanding what is it. So for which we need to first try to see the titration curve. So titration curve is a plot of pH versus charge. Okay, pH versus charge. Now, here the pH values will be from 0, 1, 2 and so on. And every amino acid has a characteristic PI, correct? So now the typical curve looks like this. Now here in this video, I'm just going to explain you overall. I'm just scratching the surface. If you want to really understand in detail, please click on the I button. There I will be explaining in that video the exact details of each of this amino acid. For now, we are just going to take a simple example. Okay, so let us say the PI is this. Okay, this is an amino acid. Say that amino acid is X. That amino acid shows this graph, okay, which has the PI value here. Now, I'm going to give you a trick as to how to remember this. Okay, so now see below the PI, like if you see this, the pH is very low, correct? So the pH is low means what? There is a lot of H plus ions. Is that correct? Yes, pH and H plus are inversely related. So, when there is a large amount of H plus, this COOH does not want to leave its H plus. It would not get ionized to this. Why? Because we already have this in excess, no? So this will not ionize. But since there is a lot of H, it will go and form a bond with this NH2 ka lone pair. So what would be the structure at this point when the pH is low? The structure of the amino acid would be something like this. That is, it would have a net positive charge. When the pi and pH, so when the pH is less than the pi, right? Here you can see at this particular point the pi is greater than the pH. So when the pH is low, COOH doesn't lose its H plus. What happens is the H plus in the medium will come and form a bond with this NH2 and it will have a net positive charge. So when pi is greater than pH, the amino acid is positively charged. Write this down somewhere. Now let us try to understand at this point. Now at this point, what is happening? Definitely the pH is going to be higher than the pi. Now at this point, the acidity is going to be less. So there is going to be less H plus. So what will happen? Now in this case, this COOH will lose its electron to form COO minus. So now what is the charge on your amino acid? The charge on the amino acid is negatively charged. Okay, so I hope this was clear. Just remember this thing. When pi is greater than pH, positive. Pi and pH, the relation, if pH is more greater, then negative. Then you'll say at pi, what will happen? So when the pH is equal to pi, the charge will be 0, right? Because there will be equivalent charges here. This will be plus, this will be minus. So when the pH equal to pi, then the amino acid is uncharged. Okay, uncharged. Now, if you know this, you can solve any problem that we are going to discuss over here. So let us solve a question now. Now the question says a mixture of glutamic acid and lysine is separated using paper electrophoresis at these two pHs. Okay, and they have given you the result below and they're asking you which of this would be correct. Now this is what we just discussed, that the two conditions when your amino acid would have what charge. Now in the question they have given you two pHs, pH 1 and pH 12, and amino acids lysine and glutamic acid. Now, it is very clear that in this case, the pH is 1. That is, definitely the pi is going to be greater than the pH, correct? Because the isoelectric point of an amino acid is not this low. It is definitely higher than 2. So this is the case where the pH will be lesser than pi. So if that is the condition, then our amino acid is positively charged. That means at pH 1, the amino acids both should be positive charge, which is not seen in figures C and D. Because in figure C and D, here to both are negative. Here both, one is negative, one is positive, which is not the case. We know that any amino acid at this low pH would definitely be positively charged. Then what about this one? There is option A and B wherein it is the same. Now let's look at the pH 12. Now this is a higher pH and their PIs are definitely going to be lesser than this pH. So pH is greater. Therefore, the amino acids would be negatively charged. Now both the amino acids are negatively charged in this figure. So definitely answer B is a correct option. See, it was so easy to actually solve this question if you knew at what pH and what pI, what condition is C. Okay, now let us do the next question. So next question says, from this data given below, identify the protein pair that would have least mobility and would elute last on an anion exchange. Okay, now least mobility. Least mobility means that the size would be higher, right? Because jitna mota protein, higher the mass of the protein, more alus, more slow. So it will be less mobile. So more size, less mobility. Now let us see among these options which is the most highest size. Definitely the 35,000 is the highest size. So we know that our P has to be 35 because all the others are smaller in size. So that is protein B. Now in my options, P, protein B is only in option C and option D. Therefore, A and B are incorrect. Now let us go to the Q part. Elute last on an anion exchange. Now this is a very important concept. Anion exchange. What is being exchanged? An anion. So anion for an anion. So if this is the column, if an anion is going to be exchanged, what would be the charge here? Yes, anion would be like, it would be attracted to positive charge. So the charge on the resin charge is positive, and since it is an anion exchanger, it is going to exchange anion. Don't get confused. What it is going to exchange? Anion. So therefore, what is the charge of the resin? The opposite, that is positive charge. Okay. So now what are they asking? Which one will elute last? Now, since the resin is positively charged, if the amino acid is also positively charged, then there will be kind of repulsion and it will flow down. That means it will elute. So they are saying it has to elute last. Elute last meaning it should be very tightly bound. That means it should be negatively charged. Correct? Because if it is positively charged, it will flow down. It will come first. But they are asking you last, so you have to see which is negatively charged. Now for Q, they have given two proteins A and E. Let us check. So E is having a pi of 3 and A is having a pi of 9. Now, what we know is that when pH is greater than the pi, that's when it will be negatively charged. That's what we want, right? It should be negatively charged. So what do you think? Out of 9 and 3, which one would be negatively charged easily? Obviously, we are looking at the lower pi. So the lower pi is 3. So this particular protein E would be my answer. So protein E would be the one that would elute out last. If they would have asked elute out first, then D would be my correct option. I hope this is clear. Let us go to the next question. Now, what is the next question? The next question says you have a mixture of proteins which are given here. What is their order of emergence? When a mixture of 4 is chromatographed on a DAE cellulose. So DEAE cellulose is basically it is a anion exchanger. Okay. So we just discussed that if it is an anion exchanger, what will be the charge on the column? Charge would be positive. So this is a positively charged resin. Okay. So this is DAE cellulose. Now, since it is positively charged, which amino acid will elute out first? The amino acid that is positively charged will elute first. So let us check. Now the pH is given 7. pH equal to 7. And what we know, We know that if the pH is less than the Pi, then it will be positively charged. My pH is 7. So let us check which amino acid or which protein has a pH that is a Pi that is greater than the pH. So as you can see, this protein 1, okay, protein 1 and protein 8, both of these are going to be positively charged. That means these guys will elute out first. Now, among these two, which is going to elute out first? So, for that, let us see the size. Now, smaller the size, faster will be the elution. So, smaller size, 12 kilodalton. That means protein 1 is going to be eluted out first, followed by protein 3, and then you will have 4 and 5. Correct? So, option A is the right answer. Let us move on to a next question. Now, next question is a mixture of four proteins of PIs 11, 7, 5 and 3. 11, 7, 5 and 3 on DAE anion exchange is equilibrated with a pH of 8. pH is 8. Which of the four proteins would be expected to be retained on the column? Again, DAE cellulose, what is the charge of the resin? It is positively charged. So retains meaning it has to have a negative charge. So if it is negative, then it will be retained. Now, when is an amino acid negatively charged? Yes, when the pH is greater than the Pi. So, now the pH they have given you is 8. So, check which Pi is less than 8. Okay, which Pi is, oh sorry, I just made a blunder while writing here. When a particular protein is negatively charged, oh no, sorry, ज़्यादा ही record कर लिया I guess. Sorry. So this is correct that pH should be greater than Pi to be negatively charged. Right. So now you have to see ki which of the Pi is less than 8. So all of these 7, 5, 3, they are all less than 8. That means all of them are negatively charged. That is, all of these are going to be retained definitely. So who is going to just elute out? That is 11. So the option C is the correct one, right? Because it says 7, 5 and 3. All of these are going to be retained on the column, which is correct. Chalo. Next one. You are given a mixture of, what mixture are you given? Glutamic acid, arginine and valine. And they have given their PIs. And you subject the mixture to electrophoresis. These are all of the statements. So it says arginine migrates towards the cathode when the electrophoresis is carried out at pH 7.1. Firstly, what I need to understand is during an electrophoresis, we always connect the battery in such a way that this is your cathode and this is the anode. So the anode is always positively charged. It's connected to the positive terminal and cathode to the negative. Now, it is saying that arginine would migrate to the cathode. When would arginine migrate to the cathode? If it is positively charged, only then. Now, let us see if it is positively charged. The Pi of arginine is 10 and pH is 7. For anything to be positively charged, the pH should be less than the Pi. So definitely this is the case. The Pi is 10 and pH is 7. So arginine is definitely going to be positively charged. So it will migrate to the cathode. Valine and glutamic acid migrate to the anode. If it is migrating to the anode, both should be negatively charged. That is, the pH should be greater than the Pi. So pH 7.1, Pi is it greater? The pi is lesser, so pi is less than the pH. So therefore this is going to be correct. It is going to be negatively charged. So this statement is also correct. Glutamate migrates farthest. When would something migrate farthest? When it is having a small size and very low, very highly, it is to the anode. So it is going to be highly negative. So look at the pi of glutamic acid. It's very less, 3.2. That means even this statement is correct. Since amino acids are colorless, ninhydrin is used. This we are all aware. We get the purple color for detection. So the correct option for this is D, that all these pHs are correct. Okay. Now let us move on to the next question, which is our last question. So what does the question say? A small fraction of clear cellular lysate was run on isoelectric gel focusing gel to purify a protein. Okay. So it was run on an isoelectric focusing gel, meaning this is based on the pi. That is based on the charge this separation is carried out, which showed a number of sharp bands to different pi values, out of which our protein of interest was having a pi of 5.2. So they cut that. So imagine this was the isoelectric focusing gel and they had many bands. Out of this, one of their protein of interest, that is pi, had a pi, protein of interest, POI, had a pi of 5.2. So they cut out this band, and after cutting it out, they ran it on SDS page, okay, with an appropriate buffer. And on SDS, what they observed was they had 3 different bands. So what was the condition? First, you took the isoelectric focusing gel and it got separated based on their pi. Out of that, your protein of interest you took that had a pi of 5.2 and you ran it on SDS. SDS gave you 3 different bands, correct? Now they are saying which cannot be the reason for observing these 3 bands. So first says that several proteins have same pi that may be present at the single band on IEF gel. Correct. Because in the isoelectric focusing gel, the only distinction or the only separation criteria is charge. So if all the proteins had the same pi, then that could be the correct answer. That could be a reason why we got 3 bands on SDS. Second says the 3 bands may represent molecular masses of different proteins, which is also correct because SDS, any page would obviously do the separation based on the charges. The protein of interest has composed of 3 subunits. That is also possible because sodium dodecyl sulfate is a detergent and it causes, also in SDS we add beta mercaptoethanol. So this may be breaking the disulfide bonds, that is separating the subunits. So there are 3 subunits, therefore 3 bands. All the subunits must have different molecular masses. Last option says SDS page showed 3 bands different due to the differences in net charge of protein. This is an incorrect statement because our first thing only was that we separated it based on charge, and now they are saying that there are different charges, which is not possible. Okay, so definitely option D is an observation that we cannot draw from this results. If you like this video, please like it, subscribe to my channel, share it with your friends, and definitely leave a comment for me if you want me to solve similar questions from different parts of the applied component. So that's it from me. I'll see you in my next video.